I'm gonna be here for about another. You welcome. Oh goodness, good afternoon everybody. Welcome to class today. Thank you for joining me, whether you're watching live or you're watching the recording. Thank you for watching. Welcome to class today. Everything going wrong here at the end of the day. Trying to get things started here, things breaking, trying to fix them. Sorry for the delay in getting started. But I think we're good to go here now. So we're in Module 2 now. And in Module 2, we're looking at variables and conditions. So we're just going to talk a little bit today about what a variable is. We'll talk about using variables, or variables and operations, I should say. I think I said conditions there when I did not mean to. Variables and operations. In Java. And so that's going to be our goal today, is to have a look at some of that. I think we'll do this relatively quickly here, because the concepts here aren't too hard. So the first thing that I want us to talk about here is just what exactly is a variable. So a variable is essentially a container, right? So we can kind of think about it in this sort of way. A variable is a container. So imagine here we have a container. There it is. That's our container. Right? We can think about our container just like any container we'd encounter, right? Shoebox, lunchbox, tote bag, any kind of container we want, right? We got a container and we can put data into this container and we can take data out of this container. Right? That's the best part about a container, is it can hold something. Right? It doesn't always have to hold the same thing. Sometimes it might need to hold something else. And so that's the great part about a variable, right? Is that we can put something into it, we can take it out and put something else into it. It's all good. Now in Java, as opposed to some other ones, right, we do need to get a little more specific about the container we create. But each of these containers, they have a label on them, right? So think about, like, just a couple of weeks ago, everybody was taking out their Christmas decorations. And so you take down your Christmas decorations and you put them in a bucket, right? And on the side of that bucket, you might have written in Sharpie, or maybe on a label or whatever, it says Christmas, right? Or decorations, something like that, right? You have some kind of name on the side of that bucket, or on the side of that container. And that labels your container, and that creates a symbolic relationship for what goes inside of that container. So if you have, in like a Christmas decorations container, if you might have, stockings and ornaments and all this kind of stuff, you don't necessarily say, go get me the stockings. If you're referring to the bucket with what's inside of it, you refer to it by its name. You say, go get me the Christmas decorations bucket. And so that name that you put on that container, that name that you put on that bucket, has a symbolic relationship to what is inside of that bucket. So I can change data later. I can manipulate data on the fly. I can make accommodations and change things and update things and move things. But it's still going to be referred to by the name that's on the bucket. Right? And so in Java, a variable has 6 different properties. Right? A variable has a name property, a type property, a value property, a scope property, a lifetime property, and a location and memory property. For now, we're only going to concern ourselves with these first three: name, type, and value. Later on, we'll add in scope. We'll add in scope a little bit later on, but for now, name, type, and value. For where we're at, our purposes, lifetime and location and memory, we don't really need to worry about. All right, so what I'm going to do is I'm just going to head over to a replit here and just start writing some code. All right, so let me just head over to my replit window. And we're going to create a REPL, and it's going to be our Java replit. And we'll name this demo 1/22/2024. Right, so we get all of this boilerplate, all of this language here. One of the first things I can do is I can take out this green stuff here at the top. That's a comment. I can take out these tests here at the bottom. That's a comment. I want to make sure I leave that curly brace though. And I can start writing variable. Right, so the first thing that we need in a variable is a data type. It is a data type. And so if we look at our variable types here, Java is what we call a strong typed language. So when we are using a strong typed language or an explicit or strict typed language, we have to make our browser a promise as to the type of data that is going to be stored in that variable, or returned from that method or what have you. Right? So we see things here. We see integer, we see double, we see Boolean, and we see string. These are our four variable types that we typically concern ourselves with. Right? We have other types here that we could use: byte, short, long, float, char. But for our purposes with where we're at, everything should be an int, a double, a Boolean, or a string. Right? An int is just an integer. An integer is a whole number. A double is a floating point number. So we use double over regular old float there because it can hold more digits after the decimal. The ability to hold more digits after the decimal gives us a higher level of precision, making our programs more precise, which in turn makes them more valuable. Boolean returns a value of either true or false. We'll be more concerned about that a little bit later on in the course. And finally, a string. I think we talked about string. Maybe we did, maybe we didn't last time. Right? A string is just a string of characters. That's one of the trouble with teaching a couple different programming languages at the same time, especially as you're getting started. You're teaching a lot of the same concepts, so you forget what you do in one class versus what you do in another. But we can kind of think about a string like one of those old happy birthday banners you might have seen before, right? Where we kind of have the string that hangs up on the wall. And then off of that, we have a bunch of different letters that hangs there. Right, so one of the interesting things about a string is that, it's important for us to remember that our computer doesn't care about words, right? Words don't mean anything to our computer. What means something to our computer is patterns. It's ones, it's zeros, it's binary. So when we take multiple characters and put them together, that means something to us. That doesn't mean anything to our computer. So the key thing there is to look at things that way with the understanding that a string is just characters, a bunch of characters that are in a row, basically contained in the same bit of memory. Just like our string here is kind of our bit of memory. So when we read a string, we think about it in terms of words. but it's not words. It's just letters. And really, it's not even letters. It's just symbols. Right? And those symbols mean absolutely nothing to nothing to my computer, nothing to my interpreter, compiler, whatever. Right? So when we get into our REPL, if we were to start off making an integer variable, we'd start off with the keyword int for integer. If we wanted to do it for a double, we'd start off with double. If we wanted to do Boolean, we'd start off with Boolean. String, we do a little bit differently. Although we do start off with string. A thing to notice here is that string, however, is an uppercase S in string. We actually use what we call a constructor method to create a string in Java. You can create it with what we call a primitive, which is this regular, this sort of situation, right? But I prefer to use a constructor. We'll see the two different methods as we kind of progress. So we start off with this data type at the start of our line, right? And so the next thing that we do is we give it a name. So we start off, first we add our data type, then we give it a name. And so when we name a variable, we have some very strict rules for how we can name a variable. Right? It's got to begin with a letter, an underscore, or a $sign. And a $sign is kind of, being able to start it with a $sign is kind of a holdover from the old school. Right? There are older programming languages where the way that you know something is a variable is that it starts with a $sign. But no other symbols besides an underscore or a $sign, and no numbers can start a variable. Right? It has to be a regular letter, it has to be an underscore, or it has to be a $sign. And the fact that you can't use numbers in a variable name kind of trips people up sometimes. The big idea from that is that basically whenever my computer sees a number just sitting out there on its own, it thinks it's time to do math. Right? So if it just saw something like say int 2 num, right? It sees that 2 and it says, 2. That's a number. That means it's time to do math. And then it hits an N, and then it's not doing math, and it gets super confused. Right, so after the first letter, I can put numbers. So in the middle of a word, or at the end of a word, I can put numbers because the thing that came before it is a letter. So then it knows it's something different at that point. No other spaces or special characters. Can't use a space. Can't use any special characters beside underscore or a $sign. And $sign can only be at the start. Can't be in the middle. It can be any length, but we want to try to keep it short, right? And it is case sensitive. And that's one of the things that we talked about before in terms of being specific. If I use an uppercase A at the beginning in part of it, that same A has to be uppercase for the entirety of the rest of the time I write the program and am referring to that variable. We also say no Java keywords here. What is a Java keyword? Here are some of them. Abstract, assert, Boolean, break, byte, case, catch. These are all words that do something else in Java. So if they already do a thing, we can't try to make them do something else. If they already do something, we can't try to make them be a variable name or be a function name or whatever. Right? We have some examples here. Right? Will it work? This might be a good time to pause the video to try this out for yourself. Look at each of these variable names and determine whether or not this would be a valid variable name. Pause it here. Try to write it down, try to do it. And there's our answers. Right, the first one's just the word grade. Yes, of course, that will work. The second one, the reason it will not work is because of the parentheses. Remember, no special cases, aside from the underscore, which is the special character that's used in line 3 there. So since that is an underscore, that is an approved special character. So it will work. The next one will not work because it begins with the number 4. Remember, my computer sees something that starts with an integer or starts with a number, and it thinks, oh boy, time to do math. But then there's no math to be done, and it gets real upset. Default will not work because default was on the screen from before. Default is one of those Java keywords. So it will not work. Finally, $grade will work. It begins with a $. That is approved. That will work. And so we can just give these all names now. So an integer is a whole number, so I could type in something like whole number to be the name there, right? The name of a variable can be anything that you want it to be. Ideally, we don't want it to be too long. Ideally, we want it to be something that we can, type out pretty quickly, but also makes sense to us. So something like whole number there works. Double is a decimal number, so we might want to use something like decimal number there. Boolean is a true or false value, so I might do like a true or false. And then string is a word. And so this is technically, right, like if I put a semicolon at the end of each of these lines, this is what we call a variable invocation. Right, we have a variable value here where we have given it a data type and we have given it a name. So all we've done basically for each of these variables here is we've made their container. So we've made 4 containers here on lines 4 through 7. We put a label on each of these 4 containers. Right, the label on the first container says whole number. The label on the second container says decimal number. The label on the third container says true or false. The label on the fourth container says word. And so we have invoked these variables. We've created these variables, but we haven't assigned them a value. And so the next thing that we would want to do is we'd want to take data and put them in. And so there are a couple ways for us to do that. Right? Once we've invoked the variable, that name of that variable has become reserved. So we could just use the name of that variable somewhere. So if I were to say something like whole number equals 14, then I have assigned a value to the variable here. And then I might use that variable in, say, a print statement. Whole number, like so. And so now I have initialized the variable or invoked the variable. I have assigned it a value, and I am printing out that value. So if I run this program now, I should expect to see 14 in my console here, which is exactly what we see. Another way I can do it is I can do it just in line here. Right? So with our decimal number, I could just set it equal to 3.87. Right? So now I have a double variable, which is a floating point number variable or a decimal number variable that I have set the value to 3.87. So this way I initialize my variable first and then add a value to it later. This way I'm initializing and adding a value to it all in one. And the output's going to be just the same if I did something like system.out.println decimal number and run that. and it's going to do this line and then this line. So we end up with 14 and 3.87. Boolean holds a true or a false value. I always forget whether it's uppercase t or a lowercase t based on the programming language. I think Java might be lowercase. It is. Notice that it does not have quotes around it, so it is not a string. System.out.println true or false is going to give me my results there. And it gives me true. Right? It's interesting, some programming languages use uppercase t's in true and false. Others use lowercase t's in their Boolean values true and false. Note that a string Boolean, a string value of true or false and a Boolean value of true or false are two very different values. And that'll be something that we get deeper into later on in the course. Now, we said a string is different. And it doesn't necessarily have to be, right? Like, I can set this to be equal to some string value. And we know it's a string value because it's in quotes. And if I were to print this out, system.out.println word, it's going to make me put my semicolon there at the end. And it's going to give me that string value. But if we do that, we're not taking full advantage of the string class. And I do mean to say class there. Because if we look at the S in string here, as opposed to the B in Boolean, the D in double, the I in int, we notice that that S in string is uppercase. And typically when we see an uppercase letter at the start of a reserved keyword in Java, it means it belongs to a class. So just like when we see this here, class is main and the M in main is uppercase. There is a class that is in Java called string, and that S in string is uppercase. That's how we can tell that it is a class. And so since it is a class, we can make an object of that class. And so this allows us to make an object instead of just what we might call a primitive, which if we look at the way we have everything now, everything is currently in primitive notation, where we just have it as, int whole number equals number. Right? In this case, what I'm going to say is I want string word to be a new string. This is my string. Right, so what this does is it creates a new object of my string class in memory, so it's more efficient memory management. Handles the string a little bit better on the back end, and does basically the exact same thing. And so this is the way that I want to handle string in context with creating a variable. Right, so if we run this now, we see word is now this is my string, and we can see that it's going to work a-okay. Let me clear out the console here to put that higher on the screen, and we get this is my string. Right, and so our variables in general here are pretty simple, right? Like we have an integer, we can initialize our variable, we can add value, we can add a value inside of that container, right? So now we have 4 containers initialized, 4 values inside of each of those containers. I could also reassign those values if I wanted to, right? By just referencing the label on the container. And as long as I put the same data type back in there, it's going to change that value to be whatever it is, right? So if I maybe make a copy of this line, put it here, we can see that at this point in my program, when my compiler gets to line 11, the value of decimal number is what we've declared here on line 5, 3.87. So when we get to this point, it will print out 3.87. But immediately after it prints this out, it changes that value. And it changes it to 8.5238. And so when we get down here to line 16, it will print out that second value of the variable. Like so. Right? We can see here 3.87 at the time that this was ran, that's what the value of that variable was. Then we changed the value of that variable so that when we ran that again, it became something completely different. Which is pretty cool, right? Like we can change values of variables and change things around. This will become especially important later when we get to things like conditionals and loops and stuff like that. Right, and so that is sort of the quick concept of variables in a nutshell. And then from where we're at, we would also want to use operators along with our variables. So Java uses basic mathematical operations, plus sign, minus sign, asterisk for multiplication, slash for division. There'll also be some others that we use later on, right? We'll talk about the modulo or modulus, which allows us to get the remainder of a division problem. Might just go ahead and look at that here in just a moment. But most of the things that we're going to want to do, we can do with our basic mathematical operators. We can do just by adding, subtracting, multiplying, and dividing. There's also a math library that we can use as well that we'll discuss a little bit later on that can extend our mathematical operations a little bit as well. One of the biggest issues that we have in Java when it comes to numbers is rounding errors. When we look at floating point numbers, or especially long decimal numbers, they're really only ever approximate. Right? For example, if we look at something like pi. Pi extends off into infinity. But I don't have an infinite amount of memory in my Java program to store a pi double variable. So at some point, I'm going to want to take that from a precise value and turn it into an approximation. And it is at that point that rounding errors could start to occur, right? Because now I have rounded this pi variable, or I've done some math and I had to truncate another number, right? And so these rounding errors give us something pretty interesting, right? And it's that 1/10 is 0.1, which is a terminating fraction in a decimal notation. But if I did the actual division problem, Well, it gets a little bit weird in binary. Right? Again, this is binary. This is a binary thing here. Right? Like in the way that we understand decimal notation, numerical notation is, 1/10 is 0.1. In binary, 1/10 is written as 0.00011. And this part here is repeated into infinity. And like you might have also heard that there is an old sort of meme, and it comes out of this, that 0.999 and continuing equals 1. Right, and that comes out of this fact that like 0.1 is a non-terminating, repeating fraction in binary. So it's just easier for us to consider things in this way. And so since binary, which is the language our computer speaks, since it doesn't see 0.1 as a terminating value, that is a repeating value, regardless of the type of math problem that we're doing, if we're using floating point values, it's always going to be just approximate. It's never going to be perfectly precise. Now, we do get incredibly close, right? Like, we're not talking about the difference between, like, 5 and 100 here. We're talking about the difference between 0.0001 and 0.00001. Maybe not even that much, right? Like, we're talking about infinitesimally small differences that are still differences. So there are some things that we can do to kind of fix it, right? There are some libraries that we can do to fix it. And then we can also use ways of representing decimal numbers as integers, and then manipulating the output to look like floating point numbers. So instead of being whole numbers, they're actually, or instead of being decimal numbers, they're actually whole numbers. And so the typical way that we do this is we use the big decimal library to do this. And so this is something that we'd actually kind of talk about a little bit more a little bit later on. There is a library called Big Decimal. And so we can examine that here really quickly. To use Big Decimal, I actually have to import Big Decimal. So this is not something that you would necessarily need to know right now, but this is to make you aware of it. I would need to import java.math.big decimal. And so this allows me to help with precision here. And so it's going to allow me to be able to create an object of our primitive double value. Which is going to be way better off for me, right? So I might want to create a double here, like our decimal number here, and then pass it to a big decimal value. So I might say like let's see here. I believe I want to say big decimal equals new big decimal number. And so that does nothing to how we actually perceive the value here. And I would actually need to change this name, right? So we would call this big decimal number. Or actually, hold on. This would be big decimal, and we actually have to give it a name. New big decimal. Now we've got a thing. So I could print new big decimal. And the way that that shows us as it prints is going to look no different, except for the fact that it is going to look very different. All right, you can see here that that value that it's created here is the equivalent of 8.5238 if we don't account for, or let me think of the best way to phrase this here. So if we were to account for rounding errors, then this number here would be equal to this number here. Right? This long decimal number here would be equal to this number here when taking rounding errors into account. Right? And so that's what that's doing behind the scenes, is it's kind of doing a little bit of math to say, well, okay, well, if we didn't have this issue of rounding errors, what would 8.5238 be? Which is kind of hard to explain, right? So this is more just to let you know that this exists and is an issue, more than to give you something that you have to remember and use all the time. For our purposes, you will never need to use a big decimal. You will never need to use a big decimal. Just use a regular old floating point number, and you're fine. Right? Nothing that we'll be doing in this course requires the precision to understand the to need to know how to account for the rounding errors if you are using a specific value. Doesn't matter at all. And so one of the things that we look at when we are dealing with this stuff is if we are doing operators. So if we are doing mathematical operators as a part of an evaluation of a statement, the result of that mathematical operation should be your data type. And technically, unless you are sure it's going to be an integer, you can always use double. Right? I can use double some value or whatever I want my variable name to be, and then add two whole numbers in there. Right? And that's going to work, and that's going to do just fine. It's going to typecast those values for me. System.out.println sum value. I forgot to take out my new big decimal front line here. Whoopsie days. And so if we do that, we see it still does the operation. It just spits out a typecast value that has a 0.0 on the end of it. So if you're doing addition, if you're doing subtraction, if you're doing multiplication, if you're doing division, you could always use a double value as the type of the variable that's going to hold this equation. Because our Java is going to automatically typecast that a whole number value to be held in this container. Now, if you do know that you're going to just be using whole numbers, I recommend using an integer data type. But if you're going to be doing a division problem, basically you're always going to be using the double as your data type. So we can do addition. We can do subtraction. We can do multiplication. And again, if it's whole numbers, you can use integer. If it's not whole numbers, or if it's not whole numbers, or you don't know if it'll be whole numbers, then always use double. And it is division. Right, and I do recommend always using double for division. All right, so then if we add these to print statements, we can get our results here. System.out.print line minus value. System.out.print line mult value. System.out.print line div value. Right, and so we can see the areas where we have our double data type is always going to have point something at the end of it, whether it is 0.0, whether it is whatever. We can see here that's 52. And we can actually see an issue here in something that we've done here with our division problem. Right? Because that's giving me 2.0. But the result of 78 divided by 34 is not 2.0. It's 2 and change. So what we'd want to do here actually is, this is because we are using whole numbers here in our division problem and not decimal numbers. So we would want to do 78.0 divided by 34.0. So we would want those values to be divs or doubles. And so if we did that in a different way, right? If we made, say, double value A equals 78 and double value B equal 34, and then instead of these numbers, use value A and value B in this equation, then our computer remembers to do that for us, right? Because then at lines 13 and 14 here, where we are creating our value A and value B variable containers and putting those values in there, our compiler is looking at those and it's interpreting them and changing them from an integer to 78.0, 34.0, because we have this double data type attached to these variables. And so if we run this now, we can see that does my math for me. So that helps me a little bit better to remember that if I want precise values, I need to make sure that I'm using double numbers from beginning to end. And it actually might be interesting to see what that would look like if we did that with big decimal, right? So if we were to take an import java.math.bigdecimal, and instead of this being a double, we make this a big decimal, and this a new big decimal with those values in there. So then we see an even more precise number as compared to this number that we have previously, right? It goes out even further. 29411764764 058 058 233 234, right? So in just a regular division operator, that's where that stops. But then big decimal continues 726 743 962 or 9652, so on and so forth. Which is pretty cool, right? We can comment that out, and we can add our double back in. Now, I think I want to look at the module really quickly. So indulge me for just a moment here and allow me to look in Blackboard, just so I can make sure that I'm covering the big important things that we need to cover. I think if we've hit everything, we'll go ahead and wrap up here for today. If there is something else that I need to cover, then we will cover that really quickly. I think we're actually good here. I think we'll add some to this. In the next module, let me just look through really quickly, make sure everything is cool. I think we are cool. Don't forget that your module is like your textbook, so you've got that in there as well to be able to use. And so I think we're good for today. I think that'll be all we need to cover for today. So we will stop here. We'll hold for just a moment here, just in case anybody has any questions. If you're watching the recording and you think of a question later on, please send me an email or a Teams message. Since we're not seeing anything, we'll go ahead and wrap up here. That'll be all for today. Thank you all for watching, and we'll see you next time.